We are live. We are live with another setup. So this is going to be Tech Thursdays PC. So you guys can see down there the godlike with the 9950X, and we are streaming using the AMD 7900 XTX, but we're using the Intel Arc B580 to render the game. So we're actually playing the game with the Intel graphics card. So we're going to take a look at the performance of the Intel graphics card. You guys can see I have the overlay set up, although I don't know why the Arc shows up underneath the frame rate counter, but that's just kind of how it's set up for now. Let me see if I can change that, because I would rather have this at the very bottom. So just move this all the way down here as like the last thing on the list. Does that do anything? No, that didn't even do anything. Oh, that put the frame time there. Hold on, where's the... Okay, that moved that down there. Okay, so now we can see the Intel B580 is running the game at about 14 to 20 frames per second, I would say. So there's a lot of texture pop and there's a lot of weird stuff going on. The game looks really weird like this. You can see XESS has all kinds of weird like artifacts going on. This is Intel's latest driver with the B580. Let me switch over to controller here instead of keyboard and mouse. Okay, now we're on controller, but there's a lot of like frame latency. It's like really janky. It's very stuttery. It's very juddery. All the words, all the adjectives associated with bad frame rate apply to this gaming experience right now. This is really something, guys. Like, I'm glad I got to experience this. This is gaming on Intel's B580 at its finest. So just to kind of show that, yeah, just to kind of show the setup here, we'll take a look at it. Let's go and show everybody the graphics options. So we are playing this game on my Sony InZone M9 27-inch 4K 144 Hz IPS panel from 2022. So you can see the resolution I have selected is 4K resolution. And then if we go over here, you can see on the right-hand side, the PC specs are an AMD Ryzen 9 9950X, 16-core, 32-thread. We are running 96 gigabytes of system RAM at 6400 megatransfers. That's 4 sticks of RAM. You guys can see actually what I should do. Come over here real quick and let's make this larger. You can see this is the godlike, the X870E godlike with the Ryzen 9 9950X. Maxed out that RAM, 4 sticks of memory. That's 4 times 24 gigabytes. The reason why we do this is because this is single rank DIMMs. 24 gigabyte memory sticks are the largest capacity you can get for single rank DIMMs. So if you want to run 4 sticks of memory, the maximum you can do at like 6400, for example, 100% stability and reliability is going to be 6400 across 96 gigabytes total. We have a whole video showcasing how to do this. And then for the cooler, we are running a Deepcool LT720 360 AIO. You can see the CPU is running at like 60 degrees full load. This game is very CPU heavy. Very CPU heavy. If there's one thing that you can afford to upgrade your PC, it's going to be the CPU for this game, because the most powerful CPU that you can get is required for this game if you want this game to have a smooth frame rate, and then leverage something like FrameGen to smoothen it out. So the The flagship 16-core 32-thread, max out that 4 sticks of memory, 96 gigabytes. The GPU, Intel Arc B580. It is worth noting that we are using 2 graphics cards. This is a dual graphics card system, because if you look in the screenshot or the camera showcasing the Sapphire Nitro 7900 XTX. I don't know if I want to mess with the camera. Let's go ahead and like move the camera down so you guys can see. There is the Nitro from Sapphire, and then right underneath it you can see the Intel Arc white LED logo, because of the second graphics card. You can kind of see that 8-pin cable peeking out underneath the top GPU there, plugging into the Intel Arc B580. So later today we will be looking at how the game runs on the Sapphire Nitro, but for this stream, and I can tell the stream is kind of laggy because of the Intel GPU, but we will be looking at the Intel Arc B580 limited edition today, right now, in a second here. And then later today, we will be looking at how the game runs on that Sapphire Nitro 7900 XTX with the godlike motherboard. So, just gonna move that back. Yeah, that is going to be the setup for this stream. Also, we are going to be looking at how the game runs on the PlayStation 5 Pro, because I have the PlayStation 5 Pro set up and ready to go. So we're going to be looking at 3 different systems. We're going to be looking at Intel B580, 7900 XTX, and the PlayStation 5 Pro for comparison here on stream. So, and I may not have to I may have to stop the stream momentarily to switch over to the 7900 XTX, but we'll show the PS5 Pro second here. But just to kind of show, this is the settings. We are running the lowest graphics preset settings right now with the Intel XeSS. Intel XeSS does not have any sort of frame gen in this build of the game. And then upscaling mode, we have set it to ultra performance. So we are upscaling from like 720p. This is 720p upscaled all the way to 4K on the lowest graphics settings. So this is it. This is how it looks. This is how a brand new game in 2025 looks at a sub 30 FPS experience. Man, this is rough. 23 frames. Let's get out of the city and see if we can improve the frame rate. No, it doesn't really change. So this sort of indicates that we are GPU bound. We're 100% GPU bound. The stream should not be lagging because we're not using the Intel graphics card to encode the stream. So one thing that I've taken some measures to mitigate the probability of the stream lagging by offloading the workload to the AMD card for the stream. So you guys can see the game is using about 15% of the CPU. And then out of the memory, I'm currently using 34 gigabytes of system memory. So we're over 32 gigabytes of RAM. This is the reason why 48 gigabytes of RAM is the new standard for a high-end gaming PC, not 32. 32 is the absolute minimum. You can see I'm already exceeding 32 gigabytes, and we're running 96 gigabytes maximum. So that's a lot at 6400. And then here we have, oh, actually, you know what? I take that back. We're not using the Radeon card. Yeah, we're not using the Radeon card. So for some reason, OBS has decided to use the Ryzen CPU's integrated graphics to encode the live stream. Now, I have no control over how OBS... This is the problem when you use AMD plus AMD or Intel plus Intel. When you live stream and you have, say, an Intel CPU and an Intel GPU, or an AMD CPU and an AMD GPU, you cannot control, as of now, you cannot control how OBS selects the video encoder. Like if you click on AMD, it might use the discrete GPU, but technically it's supposed to use the GPU. I don't know why it's not using my GPU. So the XTX is literally sitting there doing absolutely nothing. And then the Ryzen integrated graphics is actually encoding the live stream. And then we have the Intel Arc B580 handling the game. So you can see it's using about it's allocated about 9.4 gigabytes of RAM. So, of VRAM, I should say. And we are on the latest driver from January. So that is that. There's a look at the CPU, 32 threads. Next month, I will be showcasing the 9950X3D. We will definitely be upgrading to the 9950X3D. So stay tuned for that. When the game comes out, the 9950X3D is probably going to be the CPU that I play the most hours with for Monster Hunter. So just letting you guys be aware of that. So if you're interested in that CPU, stay tuned because we are going to be looking at the 9950X3D in depth next month. All right, so let's take a look. It probably won't. They'll probably perform exactly the same. I don't expect it to be better than that one in gaming. I think it'll be about the same in gaming as that. Very similar to the 7950X3D compared to a 7800X3D. Okay. Let's see. Okay, hold up. Why is YouTube complaining about video? YouTube is not receiving enough video to maintain smooth streaming. What? Okay, I don't know why YouTube's complaining. Every time I stream with the Intel Arc involved, there's some kind of stupid complaint from YouTube. I don't know why, because we aren't even using the Intel graphics card to upload to YouTube. Big reason why you're looking forward to the next desktop APUs. Yeah, I want to test a Strix Halo, to be honest. I want Strix Halo with 128 gigs of RAM to see how that unified memory architecture handles stuff like this. But yeah, so this is basically 720p. 720p upscaled using Intel's XeSS. This is what you can expect. This is terribly laggy. I can't even begin to describe how bad this feels. This is actually worse looking than when we were trying the 3090 Ti at like 8K. That one had a worse frame rate than this, but the image quality at 8K still actually looked good. Whereas this looks terrible and runs terrible. So I don't know, man. This to me proves that Intel graphics cards are just straight up not viable this generation. It's so sad because you know how reviewers said the Intel Arc was so good? Oh, it's the value king, blah, blah, blah. That's complete nonsense, dude. Like, a 7600 XT could run this, like, way better. Let's try 1080p. Please don't crash. Okay, good. I thought it was about to crash, man. That thing got me scared there. The computer froze up. Okay. Thankfully, we're not streaming using this GPU because we might have hard froze right there. But luckily, Ryzen, like, caught it. Okay. Let's switch this over. Okay, actually, let's do Intel XeSS native AA because we are currently playing the game at 1080p. 1080p resolution with the lowest preset. Alright. So let's take a look. Okay, it doesn't really seem like it's any better. In fact, it feels worse. You know what? I'm just going to remove XeSS. Let's just get rid of XeSS. Just get rid of all upscaling. Okay, that actually seems like that fixed some of the frame time inconsistency, but now it's a lot more shimmery. Wow. If you weren't here yesterday evening, you missed it. We already did 6950 XT. That was yesterday. We did 3 streams yesterday. We did 4090, we did 3090 Ti, and we did 6950 XT. All 3 of them, back to back. So now we're looking at the Intel B580. This is 1080p on the lowest settings. This is it, guys. It's actually not terrible. I mean, it's like kind of, it's not playable, but it's like, I'm not going to be able to do any monster fights like this. It's just way too laggy. But just to kind of show, this is what it looks like. Oh, there's that new monster. I still have to hunt that thing successfully. Wait, current YouTube live title is still on? No, it shouldn't be. Oh, you're right. Thank you for telling me that, man. I did not even realize I started the stream with the wrong title. Okay. Ryzen 9 9950X and Intel Arc B580 4K. We'll just say 4, well, we won't even say 4K because this isn't even 4K. Okay, I updated the title. Thanks for reminding me of that. For some reason, okay, so the thumbnail was updated, but the actual title of the video was not updated. Okay. Alright, that's fixed. It's fixed. Okay, here we go. Alright, we're getting attacked by lightning. Okay. So this is it. Let's get on the mount here. This is Intel Arc B580. It's great. Hey, you know what? I don't have to worry about the stream lagging or anything. It's so smooth now because we're not using Intel for the encoding. The frame rate is really bad though, like 20 something frames. Yeah, we'll just keep this moving on auto so I can check while it's moving. So just to show everyone, we are running on the absolute lowest graphics settings. Low. Everything is on the lowest. We've turned off upscaling and we have set the resolution to 1080p. So this is true 1080p performance on the lowest graphics settings. This is what the 4060 would look like. Oh wow, the 4060 runs the game like this. Actually, yeah, it would, because it's similar. It's a similar spec GPU, yeah. All right, yeah, we're gonna take a look at PS5 Pro in a second. I have it ready to go. PS5 Pro wants to make a point here. Because this is really making, like, this is like PC Master Race looks pretty trash right now. Not gonna lie, like, this looks low-key awful. This is an awful gaming experience on the PC MR. Courtesy of the Intel Arc B580. However, we're talking like $250 graphics card versus $700 console. I wonder who's gonna win. I wonder who's gonna win. $250 GPU upgrade or side grade versus $700 console upgrade. Wow. All right. Okay. Let's see. Hold up. I need to stop this thing real quick. Okay. Let's bring the PS5 Pro in here. Let's get the PS5 Pro in here. PS5 Pro wants to enter the chat. PS5 Pro's on the way, man. PS5 Pro is coming in here. Oh boy. Things are about to get really interesting. PS5 Pro is about to arrive. Unable to connect. Hold on, is the server down? Is PSN still down? I can't connect to the PSN on the thing. Is it down? Because I know there was an outage yesterday. Unable to connect to PlayStation Network. Oh my. Okay, yeah, we can't. Okay. See, like, this is what's happening. Unable to connect to the network. RE Engine, reach for the moon. Unable to connect to PlayStation Network. Oh, we can't. Oh, man. PlayStation 5 missed its opportunity to one-up PC gaming. That could have completely destroyed the Arc. Oh, man. Desperately needed the PS5 Pro there to make an appearance, because this is actually really bad. Alright, let's try to raise the settings. Let's keep it at 1080p. Let's go to medium settings. Let's see if we can make the visuals look better. Hold on a second. Did the performance actually improve? Why is it closer to... Okay, never mind. No, it didn't improve. For a second, I thought it was going to like 30. No, it's still really bad. Wow. Let's try Ultra. Okay, Ultra settings. No, it's... Oh, man. Yeah, no, this is not gonna work. Okay, we're gonna have to leverage FSR3 and ups. We're gonna need frame gen. Please don't crash. Okay, here we go. Please don't crash. Please don't crash. Oh, it didn't crash, man. AMD to the rescue. Wow, I thought it was gonna crash. Okay, check it out. We're playable now. AMD frame gen to the rescue. We got that AMD frame gen. Now it's actually above 30. Wow. Frame gen to the rescue. Wow, you really need frame gen for this game. 100% required. This is a requirement to play Monster Hunter Wilds. This is like the first game in history, to my knowledge, that actually expects you to use frame gen to achieve playable frame rates. The developers have gone on record and stated this in multiple interviews, in Japanese interviews. So, yeah, it's gonna be very controversial in the West. Let's put it that way. Forcing gamers to leverage frame gen to get a playable experience. Well, the good news is that you can actually get a 30 FPS frame rate. Like, this is still... The visuals look worse than console, I can tell you that. The game looks way better on the PS5 Pro with a better frame rate than this. So... It's still very janky though. Like the frame rate feels very poor. Like, I mean, not the frame rate. The frame rate is around 30 or above, but the frame latency feels awful because you're using frame gen to get to 30 FPS, which is just like that's to me that's a no-no. You can't, like, no, frame gen cannot be used to get 30 FPS. Like, this is not how to use frame gen. Like, frame gen, technically, you shouldn't even use frame gen to get to 60 FPS. But I'll take using frame gen to get to 60 than taking frame gen to get to 30. Frame gen to 30 is awful. This feels so bad. Like, the frame time graph is all jittery. Look at the frame time graph. No, this is 1080p. This is actually, like, this is sub 1080p. Yeah, this is 1080p on balance. This isn't even like 1080p, man. This is sub 1080p upscaled to 1080p. This is upscaled to 1080p on ultra settings. Okay, hold on. Let's lower it. Let's make it medium. Okay, medium settings. Medium settings. Sub 1080p, upscaled to 1080p, plus frame gen. This is the result. This is the result. 40 something frames per second. Incredible. Incredibly demanding game. Incredibly demanding game. It's so hard to run. Wow. So far, out of all the systems that I tested, the best experience was Threadripper plus RTX 4090. Threadripper plus 128 gigs of DDR5 at 6400 with error correction built in, plus RTX 4090. Basically, my most expensive computer was the only one that ran this game, no problems. Which is pathetic. It's pathetic because you shouldn't have to build a Threadripper with a 4090 just to get a playable experience in a game like this. That is unacceptable. That is not how the game industry works. I shouldn't have to use a developer workstation to play this game. You know, like that's ridiculous. It's absolutely ridiculous. We have not tested XTX yet. That will be later today. This is awful. This just feels terrible. The frame pacing is all over the place. The fact that we're using frame gen to get and then like get off the mount and then it somehow like falls below 30 again. Like I don't understand what's going on. Well, it feels like the character's being dragged left and right. It just feels so inconsistent and so bad. I can't even imagine doing an actual hunt playing the game like this. Like this is not good. Not good at all. You're gonna cancel your pre-order for this game? Well, what are your computer specs? Because if your computer specs are better than like this, well, okay, I don't even know if I should say that because, like, this computer. First of all, this has like the latest generation Zen 5 CPU architecture. Yeah, it's not X3D, but I can tell you X3D will do better. But it's not gonna be like, oh, it's magically 60 FPS now just because I have X3D. Like that's not how it works. You can go back and look at the test we did with the 9800 X3D yesterday. XTX is today. And I want to test PS5 Pro, but Sony needs to get that PSN back up. 7800 X3D and 4060. Okay, yeah, see, the 4060 is just going to destroy the game. Like, it's not even going to be a good experience. 4060 is going to be like this. Like, this looks so blurry. At least now the weather's good, so we can actually look at the visuals better. But look at how everything looks. Look at how this looks. This looks like a game object from the PlayStation 2 in a PlayStation 3 game world at like 720p, and then we pass it through FSR to upscale it to 1080p. Like, this looks terrible. Look at how much noise is in the image. Look at the dithering. Look at the ghosting on the weapon as I pan the camera. Objects in the foreground exhibit so much noise and stutter. Like, this is so bad. This is so bad. Like, I don't know. It's just... And then it somehow still goes to like 18 frames per second when I just spin the camera around? Even with frame gen turned on?
Honestly, the graphics of this game simply don't deserve the kind of graphics power it requires. I just played Rebirth on my 5090 and it stays 120 the whole game without DLSS, and looks 10 times better than Wild's.
Yeah. It's RE engine. It's all Resident Evil engine. What do they call this engine? It's RE engine, but it has like another name, Reach for the Moon. People call it the Reach for the Moon. Reach for the Moon. It's like unobtainable performance. It's so hard to obtain playable frame rates because that's hence it's Reach for the Moon. You know, set the bar so high that no one can meet it. Oh, by the way, yesterday you were asking me about the X4 slot. So if you have, I know you have the MSI Ace, the X670E Ace. The bottom slot, if I remember correctly, is directly connected to the CPU. So yeah, you can install an RTX 4090 in the X4 slot at the very bottom as an encoder, and it'll work fine. However, the thing that concerns me is you got to remember the 4090 is so large, and if you plug it into the bottom slot, all your USB connectors, your header connectors for the motherboard to the case, all that stuff is like going to be crushed by the cooler. So you got to be careful if you're going to do something like that. You have to make sure that the cables on the motherboard and the pins on the motherboard aren't going to get messed up from installing a thick graphics card. The other thing too is you need a really, really large case. Like you would have to have a full tower case, because installing a triple slot, or in some cases a quad slot GPU at the very bottom of the motherboard is really not going to fit, because it's going to run right up against the power supply. So there's a lot of challenges with doing something like that. If you want to install a second GPU at the very bottom of the motherboard. But yeah. Yeah, no, I agree. I think the game... I think it was... I don't know who decided at Capcom to use... Like, I understand where they're coming from. Like, they didn't want to spend money on licensing a Western engine, like Unreal Engine or something, just to make this game. It's weird because Monster Hunter World... Some people have cited that Monster Hunter World was very hard to run when it first came out. And that is true. Because I remember the GTX 1080. The GTX 1080 could only do like 45 frames per second at, I think it was 1440p at the time. So at 1080p, it was like around 60 or less. I have to go back and look, actually. I think maybe Tech Power Up has an article about it. From way back. Yeah, they did. They did do it. Okay, I kind of want to show this because I think people don't remember what that was like in that era. Yeah, here we go. Oh, wow, they tested 4K all the way back then? Yeah, I remember this. See, look at this. This is Monster Hunter World. Monster Hunter World. This test was done August 10th. August 10th, 2018. This is before 20 series launched. Look at the performance. Oh, look at how much VRAM it took. At 4K, Monster Hunter World only used like 3.3 gigs of VRAM. But here, the thing is, no one was gaming at 4K in 2018. Like, no one was seriously gaming at 4K. This was what I call the 1440p era. So, for reference, back then, when I was gaming in 2018, I was gaming on 1440, 144 hertz monitors. So, for me, the relevant number here is the 1440p. So I immediately look at 1440p, and sure enough, okay, so I was wrong. The GTX 10... So is this the 4K result then? Okay, never mind. I don't remember what I'm thinking, but I remember the GTX 1080 was like sub 60 at 1440p. So, oh, you know why? Okay, I remember. Because he has volumetric turned off. Volumetric... Did he do volumetric turned on? He didn't do volumetric turned on. That's why. So when you turn on volumetric fog, the game, the GTX 1080 and the Vega 64 drop to like 45 frames per second. You lose so much FPS from that one graphic setting that I think my mic is peaking a bit. Okay, so you lose a lot of FPS from that one graphic setting. But in this game, in Wilds, there's no one setting that causes the game to dip so poorly. So you guys can see 1440p, the Vega 64 and the GTX 1080 were above 60. And technically, the 1080 Ti was very close. But yeah, the 1080 Ti, or did I say 1080? I meant 1070 Ti. 1080 Ti was like 86 FPS, but then you go look at 4K and like nothing, no GPU. No GPU could handle the game at 4K in that era. And that is, this kind of like, this proves my point of games. This game, Monster Hunter World, was so hard to run back then that even at 1440p, like there was arguably only one GPU that could sustain well above 60 at the time. So Monster Hunter World, because a lot of people don't seem to remember how hard it was, because I remember there was a whole bunch of people complaining about poor optimization, developers are lazy. That narrative has never changed. That narrative has been going on for like 10 years. Like back then, people were like, oh, I can't run the game at 60 FPS on my brand new GTX 1060 or my RX 480, when these people don't understand that those are not like 1440p graphics cards. But let's see how they do at 1080p. So yeah, see, look, the same individuals, guess what? 1080p on an RX 480, 55 FPS. GTX 10, okay, these are the 3 gig, okay, hold on. So look, 1060, just under 60 FPS. It's like a rounding error. RX 580, 64 frames per second. R9 Fury X, 72 FPS. 980 Ti, 73 FPS. GTX 1070, faster than a 980 Ti. Faster than a 980 Ti. Jensen himself said it on stage. GTX 1070, faster than a 980 Ti. Well, there you go. Sure enough, it's faster. But you know what's faster than that? Vega 56. Vega 56, 91 FPS. So if you were playing at 1080p, like 1080p was good, I guess, for like Vega and anything lower end. But most people on 1080 Ti were playing the game at 1440p, and that was why I consider 2018 the era of 1440p gaming. So we're no longer in the 1440p gaming era. And that's the reason why, with all this upscaler nonsense, we live in a world now where game developers only design the game around 4K resolution, and they leverage upscalers. And that's the reason why if you watch a video like Digital Foundry, for example, not to pick on Digital Foundry, but they will view everything that they analyze from the lens of 4K resolution. So if you're not on a 4K monitor, you're left behind by the mainstream tech media and the gaming industry, because when they look at when they evaluate things like these presets, for example, they look at it from the point of what? Something is interrupting me. Oh, we got raptors. We got raptors. These things, they need to get away. Go away. Really? Okay. Man, I can barely even see it. The graphics are so bad. This thing attacked me, so there you go. That's what you get. That was awful, fighting that thing. The frame rate was so bad. Anyway, the point is, we live in a 4K world now when it comes to like streaming media and movies and all that stuff and games. So the thing is, when a media outlet like Digital Foundry has to objectively evaluate, like the performance of something, and if they have to leverage upscalers, they're going to look at it from the frame of reference of 4K resolution. So that means, like if they say quality preset means 1440p. But if you're not on 4K, like in this case, I'm on 1080p, quality 1080p does not mean 1440p. It means some resolution that's less than 1080p. And I don't even know what that resolution is. And that's the reason why 4K is really the only logical standard in this day and era. In this day and age. Please don't crash. Okay. It didn't crash. Good. Okay, I'm amazed it hasn't crashed yet. So, now we're playing the game at 4K resolution. So 4K resolution with upscaling. And here's the thing. Quality 4K means 1440p. Balanced 4K means some resolution lower than 1440p. Performance means 1080p upscaled to 4K. And then ultra performance is probably like 720p or something upscaled. So this is, and then native AA is essentially 4K. It's like the render resolution. So let's play the game at 1080p. So we'll go down to performance. So here we go with the frame gen, and there you go.
I'm hearing NVIDIA driver may be affecting the 40 series too.
You mean the one that's bricking the cards? You know, I'll tell you a weird story about that. So, in order to prepare for the live stream for yesterday, for the Threadripper plus 4090, I went and I upgraded my NVIDIA driver because the driver on that computer was from like September or August of last year. It was like a really old driver. So I upgraded it, and you know what happened? All my monitors went black, and they didn't come back on for like almost 2 minutes. Because I was sitting there and I was like, because you know when you upgrade the driver, you know, sometimes the monitors like flicker and then they turn off, come back on, and then like your windows get moved around slightly sometimes, not all the time, but sometimes. So I was like, okay, the monitors are gonna do the little flicker thing and they're gonna come back. But I waited like more than a minute and it was like a black screen and I was like, did my GPU get bricked? What happened? Like, you know, I was a little concerned because I was like, wait a minute, why aren't the monitors turning back on? The computer's still running, the RGB on the keyboard's still there, and I was like looking over at the computer, and I was like, okay, the GeForce RTX logo is still illuminated on the graphics card, so Windows still is there with the GPU, and then like about 2 minutes, then they came back up, and the window, the install window was like way over on the other monitor, like on the right-hand monitor, all the way in the bottom corner. It was really weird. That's never happened before, updating drivers on an NVIDIA card. So I was a little bit concerned while that was happening. But, I mean, thankfully nothing happened. I don't know. I mean, I had the AMD card was in there as well. And it didn't do anything while that was happening. And it shouldn't do anything while that's happening. But then I restarted the computer just because, like, the driver update didn't tell me to restart the computer, but I typically restart the computer regardless after doing a driver update. And then I got back in, and then I updated the AMD Radeon driver for the professional graphics card, and that one didn't do anything. That one didn't flicker or nothing. So I don't know what NVIDIA put in the latest one. All I know is the release notes say that it added support for the RTX 5090 and the 5080. I don't see anything else in the change logs. I think there was like 2 bug fixes for some whatever games that I don't play, and that was basically it. That was the only thing that I saw in there. But yeah, I've never seen that happen before, where the CPU fans ramp up to 100%, the monitors go black, and they don't come back for like 2 minutes. So I have a feeling NVIDIA may be trying to do something with the power management profile in the driver because of the very high power consumption for 50 series. So maybe that's causing some conflict with the VBIOS. I don't know, but there's a lot of theories regarding what is going on with those 50 series cards getting bricked. That's one of them. Okay. So this is, but yeah, I appreciate the super chat. YouTubers are reporting issues for NVIDIA cards. Really? Well, like, what are they saying? Other than the cards breaking on the driver update, I'm unaware of anything. But you guys can see, this is basically 1080p. So the game is playable at like 30-something FPS. But I wouldn't consider this playable because it dips too much. See, it drops to like 20-something, and then it goes back up. It's so weird. Am I showing the correct metric, though? Because why is it saying 81 watts? Hold on, let me see. Am I actually showcasing the correct power? It should be GPU 3. Yeah, no, that's it. So this game, so the Arc B580 is only pulling like 84 watts, 85 watts of electricity. What is the TDP of this card again? I don't even remember what it is. $190 watt TDP. So there is definitely some room for improvement for Intel's driver on this game, because the card isn't even 50% of the TDP. when playing the game. Yes, this is B580. Oh. You got me worried about that card now. You know what? I may downgrade the driver. I may go back and downgrade the driver back to the older one. Because I didn't have any problems with the September driver for the 4090. That's concerning. I might actually just downgrade the driver just to be safe. And then once they get like a newer one this month. Because that's the January driver. I might actually just downgrade. See, guys, I'm somebody who is... I'm not the type of guy who likes to be on the latest driver when it comes to graphics cards. I'm the if it ain't broke, don't fix it type of person. So, like, unless I'm having a problem, unless there's like a... Clearly there's a driver problem with the game's visuals or something, then I will be inclined to upgrade. But typically, if the game runs fine, and I'm not having any problems with my GPU, with my games or whatever, I don't update the driver. Like... Exactly. Like, there's no... And a lot of... So, a lot of people in the PC DIY space, the PC gamer space, they tend to want to think, oh, they're being proactive, they're going to update the driver. But sometimes that can screw you over, man. Like, the latest driver is not always the best choice, even though that's... In general, it's not a bad thing to be on the latest driver. It's just sometimes you never know if it's going to break something. So that's why if it ain't broke, don't fix it. I feel like that strategy in life is a much better way to live, because do you really want to be the beta tester? Like, I'm just being honest. Like the latest drivers are not always the best unless they literally state that they're certified for a specific game that you want to play at release. It's not really worth upgrading, because it's not like okay. Put it this way. It's not like the developers made this game and they were using the latest driver for the game. Like, the game was developed over a long period of time over a series of much, much older drivers. Which means that you would think that the older drivers work with the game. So I might actually downgrade that, because those reports on that is concerning. And the 4090 is a GPU that I do not want to have to deal with an RMA, considering how you can't actually buy one anymore. And it's EOL. So yeah, that's we might have to take some precautionary measures here to preserve that card. But yeah, this is not a good experience playing this game. Like this 30, it says 35, but because of frame gen, it's just way too jittery, and the latency feels so bad. It's so bad, and this, I can't believe this. This is 1080p. Let's go to 720p. 720p. This is 720p upscaled. Okay, it is better. It is better. Now it's definitely a more consistent frame rate. Although the stream still looks... I don't know. Are you guys seeing... Yeah, you guys are seeing like weird flickering and stuff on the stream, which is weird, because I don't see that. I don't know why Afterburner... Hold on. Maybe it's because I have this thing open. Does that fix that? No, that doesn't fix it. Why is the overlay flickering? The overlay's flickering on the stream, but it's not flickering for me. Has it been doing that the whole time? Hold on. No, why is it doing that? Man, this is an Intel driver problem. This is an Intel driver problem. Because Intel's the GPU that's being used to render the game. Why is it doing that? That is hilarious. Speaking of drivers... I mean, there isn't really much I can do if it started doing that. It wasn't doing that the whole stream, though, right? What did I change? The only thing I changed was I messed with this. So let's go back to balanced, I guess. Does that fix it? What? Oh no, it didn't fix it. It's still doing it. It doesn't do it that often though. That's weird. So wait, the lower I go on the internal resolution, the worse it gets. All right, let's do AMD native. All right, this is native 4K, I think. No, wait a minute. Hey, it fixed the problem. The game's not playable at all now. It's sub 30, but it's not doing the flickering on the stream anymore. Oh yeah, it is. It's just not as frequent. That is weird. This GPU is so bad. This GPU is straight up not viable. This Intel's GPU doesn't even meet the minimum, like, viable. It's just not even, yeah, well. People talk about AMD being behind NVIDIA by like a whole generation or something. You know what? If AMD's one generation behind NVIDIA, how many generations is Intel behind AMD? Because this doesn't even meet minimum viable product in my eyes. Like, this is not usable. Okay, now it seems that when the frame rate is really, really bad and the milliseconds are like in the 40s, now it's not doing the weird flicker. I don't know what's going on anymore. It just, the behavior is so all over the place. What the heck? Some monster starts attacking. Like, I'm not in a position to fight that guy. Like, with this GPU, we're not gonna fight this guy with an Intel GPU. He really wants to fight? No, dude, time out. Hold on, time out. How do I play this game? I can't barely react. Oh, I somehow parried him, and the frame rate's so bad, I have to, like, time it so far ahead of time. I have to calculate the monster's attack combined with the frame latency and the generated frame latency. Oh! What? He missed. He missed completely. Maybe I framed through him because of all the latency. This turned into a quest to hunt this thing. This is with frame gen, guys. This is with frame gen. Oh man, he's mad now. Go, frame gen, go. Well, this is actually gameplay of playing the game with the B580. 1080p with frame gen, upscaled to 4K, courtesy of AMD FSR. Oh, power clash, 24 FPS. Oh, what? I can't believe that I'm actually attempting this. I'm actually attempting to hunt this thing with the frame rate the way it is. With all the frame gen latency. And it's sub 30. We're playing the game with sub 30 FPS with the frame gen. Wait, that means we're like single digits. This is, hold on. 24 divided by like, the real frame rate is like 10 to 12 frames per second, guys. Careful, that's a furious one. Oh! Ah! Somehow perfect guarded it. I perfect guarded it despite the latency. I actually managed to perfect guard with all that latency. Looks like he's moving to a new area. Okay, we're gonna have to, I like how that boomerang flew across the screen at like 5 frames per second. Okay, yeah, I gotta fix the FPS. This is not playable. If I'm truly going to hunt this thing, I'm gonna have to lower the settings. I can barely respond. Here, we're gonna have to drop this to ultra performance, 720p with frame gen, upscale to 4K. And the whole time we've been playing this game on medium settings. Okay, here we go. Actually, you know what? We're gonna have to go all out. Lowest settings. Max it out. Alright, that feels so much smoother. Alright, here we go. Here we go. Alright, here we go. Now we got all the FSR artifacts. Alright, here we go. Here we go. Dismount attack, dismount attack. Okay, here we go. This is it. This looks... I feel like I'm playing the game on a smartphone. This looks like a mobile game right now. Oh, perfect guard. I don't know how I'm pulling off those perfect guards with the frame rate the way it is. That's amazing. I guess I'm just so good at the game. No, I'm trying to pick up the coin. I want the coin. Oh, how did I perfect guard that? What? How did I perfect guard that? How did I perfect guard that? I still haven't picked up the coin, though. Hold on, I need to heal up, for one thing. I like how this monster, like, he tried to charge the Palico and then fell down. He, like, tripped on the sand. It turned into Morse code. Okay, hold on. Yeah, I gotta fix that. Hold on. I gotta get out of here then. You know what's doing that? Somehow, running the game on the lowest settings is doing that. I think. No, that didn't fix it, huh? So that means the low upscale is causing that. So what about quality then? Yeah, it definitely seems like if you play the game on, like, a very low resolution and then upscale, it somehow causes Rivatuner's overlay to get messed up. That is weird. I don't know why that is. There. Oh, perfect guard. Oh, he missed. He missed. Wait, did he shock him? Oh, he put a shock trap. Hold on, where did he put it down? Yeah, he put a shock trap down. Here, come over here, dude. If I can get him to, if I can lure him into the thing. I'm trying to lure him. Come on. The Palico has his attention, though. There. There we go. Okay, I was greedy. I was trying to attack him when I should have blocked him there. Oh, he's going all out. perfect guard. Oh, that wasn't a perfect. Oh, that was a perfect guard. How was that a perfect guard? It's generating so many frames. Some of those extra frames are probably like added as iframes. They're probably registered as perfect guard. The game is incorrectly labeling the frames because of the frame gen being so like a high ratio of the actual frame rate is actual generated frames instead of real frames. That's funny. Wow. It does seem like it struggles with the upscaler. It definitely seems like, okay, if I drop it to 1080p. Look, let's do this. Let's do 1080p native. Okay, now the game is 1080p. Okay, I gotta turn off the upscaler though. Okay, that... What the... Hey, that fixed the overlay problem, didn't it? But the game looks worse. The game looks worse at 1080p than it looks at, like, 1080p upscale. That's weird. Actual 1080p looks uglier than, like, 720p upscale to 4K. And the frame rate is still awful. See, this is what I mean. It's like developers don't care about any resolution except 4K. They want all the game graphics and everything to only look good at 4K resolution. So they're like, hey guys, look at the progress of technology. Look how ugly games looked back in the day at like 1080p, which is completely not true. I can't believe I'm perfect guarding this guy with this terrible frame rate. This is really good practice, though. This is like good training for the real thing. Having to play the game on this awful frame rate. No, native 1080p looks worse than upscaled 1080p because I don't know, like this, they don't. It's weird to me because Resident Evil doesn't look this bad at 1080p. So I don't know what they're doing. I don't know what is up with this game. Like this looks like a Nintendo Switch game. Like with this sort of graphics, this looks like a Nintendo. This is like I feel like I'm playing a game on a smartphone. This doesn't even seem like. Look at the light. Look at the light effect. Look at how that looks. That looks so weird. (1080p with FSR). 1080p with FSR. Okay, 1080p with FSR. Okay, 1080p, AMD, native AA. Native AA. So it's 1080p with native FSR anti-aliasing. It actually does look a little bit sharper, strangely enough. But let me tell you, it feels way worse to play with this turned on. So now we add frame gen. There we go. Playable frame rate. But still not 60. We're playing on medium. There we go. This is the experience of Monster Hunter Wilds at 1080p. What does this guy do? Is this like a wyvern thing that I can use to fly? Well, that's probably... Is that the thing that can take me back to the camp? Does this game have lower than TAA? It has... Okay, so the options are FXAA plus TAA or TAA or off. And because we are using AMD's FSR AA, it disables the AA, and it uses that. So XESS, we can try that. XESS is no bueno. You know why? I'll show you why. As soon as you turn on XESS, you lose the ability to use frame gen. So let's do Intel XESS native AA for 1080p. There you go. This is Intel's native anti-aliasing. But unfortunately, we do not have access to frame gen unless we use FSR. So we cannot up the frame rate to a playable frame rate. So that's the only problem with XESS. Can somebody tell me what is the latest version of XESS? Because this game has XESS 1.3. It's 1.3 and the FSR is 3.0. Very hard game to run. XESS 2. Yeah. XESS 2 is the one that has frame gen, right? Because I really want to test the Intel frame gen. Even with the frame time graph, it's alias now. I guess. I mean, if I'm... Okay, since we're doing that, let's try lowest settings. Is this going to make the overlay flicker? It gave me like 2 to 3 frames per second better when dropping it to lowest. Yeah, apparently Intel and RE Engine do not mix. This is the best I can get it to run. Hold on. Well, here, one thing we can do. No, actually that won't work. What I can tell you is the final game will have a newer version of FSR. It'll have FSR 3.1 something, because the benchmark uses 3.1. So, but the demo is still using the old build. But I don't know, I gotta go back and look at what the XCSS version is. 1080p with lowest, with FSR lowest. We did that. You know what that does? That causes the overlay to flicker. Watch, we'll do it. Is it gonna flicker? Hey, it's actually playable like this, though. Look at that, it's like 40 now. Hey, it's actually smooth now, sort of. It's like way smoother than before. It's like 30-something FPS. Interesting. So it's, but see, like the light source. Look at that light source out in the distance. Hold on, I want to see something. Look at that light source. That light source is so low res. Look at that. As I get closer to it, the luminance box is on it. Like you can see the region where the light. Look at that. See that? I mean, the light sources look really weird. This looks like I'm playing it on a smartphone. This is like how you play a mobile game. This is really bizarre, though, that the performance is this bad. Hold on a second. Did they even list Intel's graphics card in any of their system requirements? I thought they did. Didn't they? For one of them? Minimum required specs. No, they didn't. They never listed Intel's GPU at all. So that means they never tested Intel's graphics card. So yeah, Intel's graphics card is completely not supposed to be used for this game. That's why. That light just vanished for some reason. That was weird. The little firefly thing like just disappeared. It just like despawned. It just despawned. It's like, no, the Intel GPU doesn't need to render me anymore. I'm not gonna be here anymore. It just despawned. I turned around and that firefly thing just despawned from the world. It's not on the guest list. Oh man, okay, I think I don't know, there's like nothing else to really show on here. I mean that's it. I mean that's pretty much the Intel GPU. You can you reach 60 by looking at the sky? Good question. Let's see. Nope, can't reach 60 looking at the sky. Wow. You can get to like 44 FPS looking at the skybox. Wow, that's so bad. Hold on a second. Is that what? Oh, hold on. Hey, there you go. Literally turning on FSR, like, look at the latency with the FSR, though. Look at the graph. It's getting pretty close. Wait, hold on. Is this... So this is 720p. 720p upscale. Okay, hold on. I got an idea. Okay, here we go. 720p. 720p. Ultra performance. That means we're literally taking the game. We're running the game at 144p or 130p. And we're upscaling it to 720p. 140p to 720p with frame gen on the lowest settings. Check it out. It touched 60. Look at that. It touches 60. 140p internal resolution can touch 60 FPS. With frame gen. Hold on. Turn frame gen off. Let's see. Does that help? Does that do anything? Oh, no. See, you need frame gen, because frame gen, you're in the mid 40s. So you got to turn on the frame gen to get it to go all the way up. There you go. Look at that. Intel and AMD working together. Alright, how does the game look, though? Whoa! This looks retro. Look at that shadow. Look at the character's shadow. Wow. Wow. The Palico looks like a blob. Like, I don't even understand what the Palico is. Look at that. The monster, you can still kind of visualize the monster, but like, yeah, this is... I've never actually experienced gaming like this before. The visuals look so distorted. Man. Yeah, the character is like running out of stamina. Okay, well, I guess that's it. Yeah, we'll probably end the stream here and then take a break, and then I'll have to switch it over to the XTX. Let me check if PSN's up though before we go. No, PlayStation Network is still down. Wow, that's a really severe outage. Yeah, the CPU is using more wattage than the GPU now. Clearly, Intel's... Man, look at the town. Look at how the base camp looks. Wow, this is weird. Everything is so everything is so blurry. This is like an interesting... It's like looking at an impressionist painting from the 1800s. Look at this. It's like somebody is painting like an impressionist style artwork. Look at that. Look at how it like messes with the geometry. Look, even the depth of field is off. The depth of field in the shadows. Whoa, this is cool. I go inside the tent and the NPCs are almost recognizable. Even the overlay text, the subtitles are blurry. Wow, this is so cool. Like a 70s movie? Well, I wouldn't say that. To me, it looks like one of those paintings at like an art gallery, like some Picasso painting from the 1600s or whatever. Nah, this doesn't look PS2. PS2 looks way better than this. PS2 looks way better than this. Like, okay, look at the NPC that's standing on that box. Do you even know what NPC I'm referring to? I'm referring to this guy. This dude, Jack. Look at Jack, the NPC. Look at that. Yo, sorry, but we're still getting things ready. Okay, yeah, you probably need to work on your upscaler there. Yeah, look at this. Look at all the food. Look at all those food stuff at the food stall. Look at all those wonderful vegetables. Delicious veggies and meat. The most delicious looking veggies and meat you've ever seen. Look at that. AAA gaming at its finest. This is AAA gaming right here, man. This is Game of the Year stuff. We're looking at a contender for Game of the Year 2025. No, I'm not saying that as a joke. Like, this is I'm serious when I say that. Monster Hunter Wilds could win Game of the Year. If GTA 6 gets pushed to next year, like, what other games are coming out this year that's going to be able to rival this game? Oh, great, the weather changed. Now look, the colors look more vivid now. Now it's not Impressionism anymore. Now it's Fauvism. So if you know art, this is now an example of Fauvism. Very vivid colors. Wow. This makes me want to look at like how a PS2 game looks. Final Fantasy X looked better than this on the PS2. This is cool though. Like, it looks really weird seeing the temporal upscaler do this. Now, it is a playable frame rate though. We are in the mid 40s now. So, but realistically, like, who would actually play the game like this? Nobody. You can count the pixels on the fire. Yeah, you're right. Okay, let's try to make this sharp. Let's go all the way. Native AA, here we go. We're still at 720p. So this is 720p now. See how much sharper it is? Let's do one more test before we end the stream. All the way, 4K. Put those glasses on. Get those prescription lenses out. Look at the difference in quality. So it's almost like the developers want you to play the game, or it's like, no, it's not that they want you to play it. It's like they've made the game where Oh gosh, don't freeze. Yeah, see, look. Here we go. This is 4K Ultra with frame gen. Frame gen now gets us to like 20 frames per second, but look at the difference in how sharp it looks. So it's like the developers are only making the game for 4K resolution now, and that's where we're at in 2025. Prescription lenses. Alright, that's going to be it for this stream. We're going to take a break. It's going to be... Where are we at on the time here? The next stream will start in like 10 minutes or so. Or, I don't know, maybe 10, 15 minutes. So we're going to stop the stream. PlayStation Network is still down, so we can't test PS5 Pro. Maybe we can look at it this evening. But we're going to switch over to the 7900 XTX. And we'll be back with that GPU. And then after that, we'll probably look at some other ones in the evening. We also need to test some other CPUs. So we have Intel CPUs lined up. We have 13900K at some point, 7950X3D, Intel Core Ultra 9. We're going to be testing those CPUs with the 7900 XTX. So we're going to do the 7900 XTX with the this CPU, the 9950X first, and then we'll go from there. We'll use that one as a baseline. Not really. I'm gonna try to do an hour. We've done an hour and 20, so we've gone over by 20 minutes. But we're gonna try to stick to an hour per test, no more than an hour. Maybe some of them will only be like 45 minutes, and we need to do some more hunt footage. So we're gonna try to, assuming that the game will be playable, we will actually do hunts. Audio's cutting out. Yeah, that's probably because the game is stuttering too much. Alright, anyway, we're gonna end the stream here, and we'll be back in like 15 minutes.